Hi everyone, this is Rohan here, and in this video I'm going to discuss about sun path diagram. Now, let's say we have a pitched roof here and we wish to have solar paneling on it. So, on which roof would you place the solar panels on? Will it be this roof, this side of the roof, or will it be on this side of the roof? Well, the answer to that is whichever side of the roof gets the maximum amount of sunlight for the maximum time of the year, you should place the solar panels on that side. But to know which side that is, we need to first understand that how to find the position of the sun in the sky. With the help of some graphics, I'm going to explain this to you point by point. I request you to please pay attention. Let's imagine this as a plane of observation. That means the observer will be on this plane. And it's like a horizontal disk. So, therefore, the edges of this disk will be the horizon. It is the horizon. And the center of the disk is where the observer is. Let's call that point as O. Now, let us imagine now the north direction is taken in the direction shown in this figure for simplicity in this direction. Now, let us imagine a three-dimensional globe around it like a celestial meridian. All right. And now see, if you have a perpendicular going right from the point of observation, that is O, to the top at the celestial meridian, that point is called as the zenith. So the point vertically above the observer that is touching the celestial meridian is going to be called as the zenith. Okay, and let's say at any given point of time the sun is at this position at S. Now, to make myself clear that the sun is actually on the virtual globe that I asked you to imagine, it is a three-dimensional globe around the plane of observation. I think it will be clear to you when I join this line. Yes, so when you join the zenith via the celestial meridian and touch it to the plane of observation, it meets at a point B. It meets at a point B. Please understand that the sun is on the virtual globe that you have imagined. To make my point further clear, I am joining the points S to O and point B to O. So I think now here you have a clear idea where the position of the sun is. Now, in order to measure this position, if we say that from the point of observation it is 100 kilometer to the right and certain kilometers to the to the top, then it will become very difficult for us to imagine in real time. So it is preferred to give the position of the sun in terms of angles. Now please note the point N here. I'm going to do some graphics here. So here this angle starting from north and going in the clockwise direction here, okay, this is nothing but angle NOB. Angle NOB. Of course, this is a horizontal angle. So here, if you know this angle, then from the north you can reach up to the point B. Am I right? And from here, if you know this angle, that is nothing but angle BOS, if you know this vertical angle, then you can know the position of the sun. So in order to know the position of the sun, we need basically two angles. One is the angle NOB, which is called as the azimuth angle. It is a clockwise, it is measured in the clockwise direction. And we need another angle, which is angle SOB, that is this angle, which is measured upwards from B, and this is called as the altitude angle. So these are the two angles with the help of which we can determine the position of the sun at any given time. Now I want to discuss a little further about azimuth. Just see that from here the sun may be here also, it may be on the other side also. So based on the position of the sun, the azimuth angle, that is NOB, can start at 0 degree at north and it will become 90 degree at east, it will become 180 degree at south, it will become 270 degree at west, and it will be 360 or 0 degree again coming back to north. So the range of azimuth angle is 0 to 360 degree. 0 to 360 degree. However, please see, here the altitude angle is starting from where? It is starting from the horizon. So you can say that when the sun was at this position, it must be having a sunrise. It must be having a sunrise. Now it will go up here, it will go even further up, and later on in the day it will go down like this and up to this horizon point, right? And beyond this, what will happen? This is the sunset. If it goes down the horizon, it is sunset, so there is no sun in the sky. So therefore, if you see the range of altitude angle, it starts from 0 at horizon, and the maximum value is 90 degree at the zenith, and again it starts falling, so from 90 again to 0. So the range of altitude angle is 0 to 90 degree. I'll just repeat once more. The range of azimuth angle is 0 to 360 degree, and the range of altitude angle is 0 to 90 degree. Now, with this information that we have gathered, how about if we can represent the entire path of the sun on one diagram? That is nothing but sun path diagram. Now, please see that. Now imagine that your eye is at the zenith and you are looking down at the point of observation. Okay, your eye is at the zenith and you are looking down at the plane of observation. Okay, now let's first divide this plane into north, east, south, and west. And of course, this point is nothing but your point of observation. You are here. This is the point. I mean, this is the point of observation. You are looking at it from the zenith. Now, let us, so these are the cardinal directions, north is southwest. Now further, I would like to draw the azimuth lines. Azimuth angle, as I told you, varies from 0 degree at north, and going clockwise it goes up to again 360 degree at north. So these are shown by the radial lines. Okay, and these are called nothing but the azimuth lines. Now I wish to show the altitude lines, which will show the altitude angles. So therefore, they will be concentric circles here, starting from I'm sorry, starting from here, which is the 0 degree at the horizon, isn't it? The horizon, we said that it is going to be 0 degree, and from there 10 degree, 20 degree, 30 degree up to 90 degree at the zenith. So basically, what you have here is a graph having the radial lines as azimuth lines and the concentric lines as altitude lines. All right. Now, here is something new. This here that I drew in yellow is called as the date line. It is called the date line. Now here, if you see, it starts from the east and it ends in the west. It denotes that the sun rising in the east, and it has to be given with a time, let's say 3 minutes past 6 in the morning the sun has risen, and in the west it is sunset at 6:54 p.m. So this is the entire path of the sun on any particular day. Okay, of course it can be here also, it can be below also. I'm just showing you as an example that this may be one of the date lines. All right, and in the date lines, apart from the sunrise and sunset, we show some of the key times, that is 9 a.m., 12 noon, then 3 p.m. and 6 p.m. Right? So here you can see, you can trace the position of the sun based on the azimuth line and the altitude lines. For example, if I want to find out, okay, if I want to find out that what is the position of the sun at 9 p.m. Okay, so you see it is lying between azimuth line of east, that is 90 degree and 120 degree. So somewhere the azimuth is roughly at 100. Azimuth angle is 100, and you see this line is what? This is the 10, 20, 40, 50, 50. This is the 50th line. Am I right? Yeah. So accordingly, you can see the altitude angle as well as you can see the azimuth angle. So with the help of that, you can find the position of the sun at 9 p.m. Similarly, any point you can just find out based on the azimuth line and the altitude line that it is on. And of course, if it is intermediate, you will have to interpolate that. Okay, so this is one date line. That means on one particular day, any particular day, it will look like this. Now, as you know, the sun rotates around rotates and which causes the day and night, as well as the revolution is there, which causes the seasons. Now there are two extremes. One is the summer solstice and the other is the winter solstice. Summer solstice is the time when the sun when the I'm sorry the earth is closest to the sun, and the winter solstice is when the sun is when the earth is farthest from the sun. So it is very important for us to also locate the path of the sun in the sky, okay, during the summer solstice. So here may be the path of the sun on the summer solstice. I'm not showing this much in too much of details as 9 p.m 12 p.m. Just see that this is the path on summer solstice, and this may be the path on the winter solstice. Okay, usually these are on 21st of June and 21st of December. Now see, if this, just look at the center, if this is your site or the location, right? So the sun will be in the sky throughout the year in between this patch only. That means in between the summer solstice and in between the winter solstice only, right? So this entire region is of importance to you. The one outside is not of importance to you. It is very important for you to know this region, okay? And this is called as the annual variation. This is called as the annual variation. So the position of the sun in the sky above your site will vary from here to here, from the summer solstice line to the winter solstice line. So this is basically what a sun path diagram is. I just want to show the same for you as a practical one. So this I have downloaded from gaisma.com. I encourage you to please visit the site and check out the sun path diagram for your location. It is quite easy. Let's decode this. Of course, this north 30, 60, all of these are the azimuth lines, right? And this 10 degree, 20 degree, these circular lines, the concentric lines, are the altitude lines. Now just see, this orange path is the path of the sun today, is the path of the sun today. Okay, so it started at 6:30 in the morning and the day will end at 6:51 here in the west, and 9 p.m 12 p.m 9 a.m 12 noon 3 p.m 6 p.m, all of that is given here. Also see, June solstice, that is nothing but the summer solstice, is the line that is here. The days will start at 6:1 and end at 7:18. You can see how big the day will be. Okay, and here below is the winter solstice, that is called here as the December solstice. The day starts at 7 a.m in the morning and ends at 6:05 in the night. So you can see the length of the day is already short. And this entire yellow part in between the summer solstice line and the winter solstice line is nothing but the annual variation. Okay, so I hope this is clear to you. So for and so forth, based on the position, the various sun path diagrams are available. I encourage you to again go to gaisma.com and check out the sun path diagram of your location and study it. All right. Now, I think I have explained all of that things to you. Just I want to quickly go through the definitions and all. Already, all of this has been discussed. So you can actually pause the video and just look at the definitions here. So a sun path diagram or solar path diagram or sun chart or solar chart is a visualizations of the sun's path throughout the sky, isn't it? So it is basically a visualization of the sun's path through the sky. It refers to the apparent significant seasonal and hourly positional changes of the sun and length of daylight Do we get to see the seasonal changes? Yes, we get to see from June 21st to December and everywhere in between, right? And do we get to see the hourly positional changes? Yes, as I told you, starting from the sunrise to the sunset in between 9 a.m., 12 p.m., all of those things are already shown. So, and you can know the length of the daylight also. You get to know the sunrise and sunset. So, you know the length of the daylight also from the sun path diagram, and this is obvious. The sun rotates and orbits around the sun, and that is why it has the apparent change in the positions in the sky. Now, the relative position of the sun is a major factor in the heat gain of buildings and in the performance of solar energy systems. Now, in a country like India, we want our houses to have minimum heat during the summer. And how are we going to ensure that? We are going to ensure that by our knowledge of the sun path diagram. And also, if we want to have solar energy systems, is that how we are going to ensure the performance, the better performance, by knowing the sun path diagram. Accurate location specific knowledge of sun path and climatic conditions is essential for economic decisions about solar collector area, orientation, landscaping, sun shading, and the cost effective use of solar trackers. So basically, if you want to have any solar energy systems in position, you need to have a good knowledge of the sun path diagram. Now I'm just going to show you some definitions here. Already we went through this. Azimuth lines. Azimuth lines are what? The radial line originating from the observation point, right, from O towards the horizon and measured clockwise from north direction. This is very important. It is measured clockwise from north direction at regular intervals. Usually what we saw is of 30 degree. The intervals are of 30 degrees. So north 0, 30 degree, like that, and 90 degree at east, so on and so forth. It depicts the azimuth angle, isn't it? It depicts the azimuth angle. And the value of azimuth angle, as I told you in 3 slides ago, the value of azimuth angle varies from 0 degree to 360 degree. Now see, altitude lines. Altitude lines are the concentric lines, right? That 0, 10 degree, 20 degree, 30 degree, up to 90 degree. Okay, the altitude lines are concentric lines depicting the altitude starting from the horizon, that is at 0 degree, to the observation point, that is at 90 degree. You're already knowing this. Then date lines. Date lines start on the eastern side, right, of the sun path diagram and run to the western side and represent the path of the sun on one particular day of the year. Okay, and similarly, if you draw the sun path diagram for all the days, it automatically becomes the sun path diagram. Then annual variation, the area of the sun path diagram between the date lines on summer solstice and winter solstice, right? On summer solstice you are going to have one date line, on winter solstice you have to going to have another date line, and the area in between that is going to be called as the annual variation. Okay, now let's jump on to the last part, which is what are the uses of a sun path diagram. Of course, the number one use is the proper positioning of the solar panel. Now just see here, if you know that your sun path is like this on June 31st, right, that is the summer solstice, and your path of the sun is like this on December 21st, that is the winter solstice. So definitely you would want to place your solar panels on this side of the roof and not on this side of the roof, because you want maximum output from this, isn't it? Now this answers the question that I asked in the first slide, and this is how it helps. If you know the position of the sun path, you get to have a informed decision about how and where to place the solar panels. Now, the last use, more important use of the sun path diagram is the proper to decide the proper size of windows and sun shading devices. Here you see that this may be the wall of a building, okay? And with the help of sun path diagram, we'll be easily able to know the lowest sun angle in the summer sky, right? When that will happen, it will happen on June 21st. And this is the highest sun angle in the winter sky. This may happen on 21st December. So you have this idea in front of you, right? So it makes sense that if you place a window like this, isn't it? If you place the window like this, then what will happen? You will get the correct benefit of the sunlight the way you wish to have the sunlight in your house, isn't it? So this is how you can place the window. And on the other hand also, if you wish to this may not be a very convenient thing for each and every site, in that you may have to cut the rays, so that it doesn't enter your house during the summer. For that you may need a sun shading device, or the sunshade, which is also called as a chhajja. It is also called as a chhajja here. So you get to have a much more informed decision about what will be the size of the chhajja. Okay, so with this, I hope you have understood the fundamentals of the sun path diagram, what are the features of sun path diagram, and what are the uses of sun path diagram. So with this, I end today's video. Thank you for your attention.